Hey everyone, this is Vu from Phoenix LiDAR. Thanks for logging in. This is our fourth webinar and we're really excited. So first of all, a little bit about us. Conrad, would you go to the next slide? Awesome. So for those who aren't familiar, we're Phoenix LiDAR Systems. We do two big things. First is custom survey grade LiDAR mapping systems. But second, we also automate a lot of the process. We've studied the LiDAR workflow from start to finish. So we have, for example, the Phoenix Flight Planner, which takes a lot of the guesswork out of planning a flight, the acquisition software that we built, and then LiDAR Mill, the first cloud post-processing platform on the market. So today we're really excited to present a little bit more information on the third bullet point here. As you see, we were the first in commercial UAV LiDAR. But the third bullet point there is that we launched the first fixed-wing VTOL UAV LiDAR system. These are robust, and so one of the great things about the data sets that you'll see today are that some of this is really difficult detail to capture, or there are different challenges that some of our clients run into. So launching a system like this addresses many of those. So just to put everything into perspective, as our fourth webinar, the first one was on UAV LiDAR use cases. The second was on that flight planner tool that I mentioned earlier. And the third was on just a part of post-processing featuring LiDAR Mill. So this fourth one, we're going into challenging UAV LiDAR circumstances like power lines, heavy vegetation, corridor mapping, wide area mapping. So before we jump into the data set, I wanted to introduce some of our teammates. On the call today, we have Conrad, our Senior Post-Processing Manager, who will be leading a lot of the discussion regarding the data sets. Eric McNeil is one of our post-processing engineers. He'll be on the call as well. Sam is our Chief Pilot, and Eric Agnello is our Director of Sales. We have a lot of other team members here to answer questions just in case. At the bottom of your screen, you'll see a chat button. That chat feature allows you to ask questions or to comment. A lot of our team members are sitting on the chat room to help answer questions. If you have questions specific to the presentation and wanted to ask the presenter, you can click that Q&A button there, and all the panelists will get an alert saying that, hey, this person had this question. So if it's something that we can bring into the presentation, we'll go ahead and stop the discussion and ask your question of the presenter. So the three data sets that we'll see today, first, covers medium vegetation and some residential structures. This will be data captured by our Phoenix Terrahawk CW20 UAV with the Scout Ultra system. The second is going to be a corridor of power lines with some vegetation, and that was the CW30 with the Ranger LRT. That's the strongest configuration of our Ranger LiDAR system. And the third is dense vegetation in a very wide area. Now, each of these has really impressive certain challenges that we address. So Conrad will go over those. But before we jump in, I wanted to pass the mic on to Sam, our Chief Pilot. He's going to discuss a little bit more about fixed-wing VTOL LiDAR. I'm sorry, fixed-wing VTOL UAVs. Take it away, Sam.
Hey, thanks a lot, Boo. Yeah, today we're going to take a look at our...
One more time, you were muted.
Ah.
Try it again.
You got me now?
Got you now, go ahead.
Okay, great. So today we're going to talk about our TerraHawk VTOLs. Whoa. Is that better?
We love hearing your voice, but it's so loud.
Yeah. Is that a little better? Is that acceptable?
It's a lot better, yeah, thanks.
Okay. So we have two VTOLs right now that we've integrated our systems into, and we're getting really great results from both of them. The first one that I'll talk about is our Terrahawk CW20. This is a 3-meter wingspan VTOL. It does use a hybrid powertrain, so we have electric multi-rotors for takeoff and landing, and then we have a gasoline engine that does the majority of the acquisition for forward flight. This aircraft has a maximum takeoff weight of about 40 pounds, so we're able to fly this in the United States with all of our regulations being under the 55-pound mark. Typically with this aircraft, we're flying a payload like the Phoenix Scout Ultra, and we're usually flying at a maximum of 100 meters AGL. With this aircraft and this system, we're able to scan about 20 square kilometers at 100 meters AGL. If we fly a little bit lower with a little bit more overlap, we're flying around 15 square kilometers. I've had a lot of experience with this aircraft, and it's proven to be very reliable. The transitions from hover to forward flight and forward flight back to multi-rotor mode are quite smooth. Both of these aircrafts that we're discussing today use real-time kinematics, so RTK positioning in flight. This allows us to land on a dime. Basically, this aircraft is going to land exactly where you take off from consistently. So you do not need a full-length runway for belly landing. We're able to operate from smaller areas and cover much larger areas, all while reducing risk on landing. Our other aircraft that we've integrated into is the Terrahawk CW30. This is a larger aircraft. It's a 4-meter wingspan, maximum takeoff weight of just over 70 pounds. So that means that if we want to fly this here in the States, we do need a certificate. We need a waiver to fly it here, but at many other locations, we're able to fly it without an issue. So the CW30 will fly for a maximum of 2 hours with our payload, and we can cover pretty good areas. So with just LiDAR, you're able to cover 40 square kilometers to maybe 50 square kilometers if you fly at a higher altitude. All of these flight parameters are dependent on your requirements. What density do you need on the ground? What is your accuracy requirement? So we've worked with these aircraft quite a bit, and we're getting very, very good data. So this is our CW20 and the Scout Ultra.
Sure. And so just to talk a little bit more about the Terrahawk CW20, we have Grayson Omans, our CEO. I think I said that right. Go ahead, Grayson.
Hey, guys. So the CW20 is a new frontier for UAV LiDAR. And part of the reason that we're offering it is that the multi-rotors that we have right now, which I call leapfrogging, they cover fine, a square kilometer, 2 square kilometers, 3, whatever your projects are. But we know we're entering this new frontier of power line mapping or larger area mapping. And the CW20, part of Phoenix Challenge has always been, how do we keep that LiDAR sensor in the air as fast, or as long, not as fast, as long as we can, and as slow as we can. But we've integrated into multiple different fixed wings, from belly landing electrics to most of them. And the VTOL DRTK fixed wing is by far the best solution, just because this DRTK, between the base station and the rover, the UAV actually lands 2 centimeters away from where it took off. So it has very good positioning. And with all of these VTOL fixed wing systems, they have another layer of redundancy. Everybody talks about a parachute, but when you're flying at 100 meters, a parachute really doesn't have that much time to react at 25 meters per second. So what the aircraft does is, say if it senses the gas engine turn off, it'll automatically turn and head back to home as far as it can go, and then kicks into emergency mode where the multi-rotors kick in and it self-lands. Now, of course, there's that use case that there may be a pond or a lake or trees there, but landing in a multi-rotor mode is a lot better than landing at 50 knots straight into the ground. So your chances of the payload walking away from that are quite good. So overall, the VTOL fixed wing strategy, is the next frontier. Our challenge right now is, of course, regulation. We will be faced with this whole beyond a visual line of sight regulation in the States, but in other territories, they don't have this regulation, where the CW30 will be a good fit. And we have some that are pioneering the CW30 in the States, but a big benefit that has developed is the introduction of this Scout Ultra. For those that are in the States that want to cover large areas, the Scout Ultra is really a perfect combination with the CW20 because CW20, we're getting close to 2.5-hour flights. And with this, the Scout Ultra, finally, we can fly at 100 meters AGL, whereas before we had to fly at 50 meters, which any of you fixed wing guys that know that that's quite a pucker moment. There's not much reaction time at 50 meters, and we need to be higher. So with the 100-meter AGL capability and that 200-meter to target range, it really opens up the possibilities with this sensor. Now, sure, we're not getting as many returns with this sensor as we would with some other sensors, but we call it probabilistic penetration. We have 32 lasers fanned out at +15, -20 degrees, and are able to look forward, down, and backwards. So we have a higher probability of penetrating that canopy. And you'll see that data coming up with Conrad. So this sensor really is this whole system is a perfect fit for these, for not only power lines, but also for vegetation penetration, for general surveyors of larger areas that want to have this capability. And not to mention that this Scout Ultra the Scout Ultra can be removed from the CW20 and installed onto a multi-rotor. So it's a dual-use payload, even on a ground vehicle as well. So as well as the Ranger LRT can be removed from the CW30 and mounted on a car or a R-44 helicopter. So lots of options with these, and it opens up a whole new. It's actually, for those of you that have been in this multi-rotor leapfrogging side, it's quite foreign because you're sitting around for 2 hours not knowing what to do. It's just it's in the air for so long, and you can cover so much area. So we're excited to offer these, and I'm excited to have Conrad go over some of this data so you get a good idea of its capability.
Take it away, Conrad.
All right. Hello, everyone. I hope you're all having a good afternoon or evening or morning, possibly, depending on where you are. First data set that I want to take a look at is a medium vegetation and residential area. This was collected with the Terrahawk CW20 and Scout Ultra. This is sort of a sneak peek at some of the Scout Ultra data. So let's take a look at it. This mission was flown at 100 meters AGL, cruising speed of roughly 25 meters per second, so moving along pretty fast. Considering those two parameters of how high we were flying and quick we were moving, the impressive thing about this data set is just the density of points that reach the surface. Each flight line within this project was achieving approximately 20 points per square meter. So combine 3 flight lines together, and we're looking at a high density data set, a really high density data set. The usable field of view in this data set is 90 degrees, and we're aiming for roughly 50% side overlap. So anywhere we're looking should have double coverage, maybe a little bit of third flight line in there. So this is a typical density of what you'd want to be acquiring for a project. Like Grayson was mentioning, the probabilistic penetration of the canopy, we can see in this data set there are some forested areas, and changing the symbology a little bit so that we can kind of get a better understanding of what we're looking at exactly. We can see there's some plenty of dense vegetation.
And Conrad, while you're showing this, I wanted to let you know, so Grayson offered to share this, this point cloud with a lot of people. So I'm going to post a URL in the chat box. If you'd like to browse around and poke around with our online viewer while Conrad is speaking, go ahead. I'll post that shortly.
All right, thanks, Vu. And I guess, thing that I wanted to point out was this is a dual return system, but it's a multi-laser system. So we're sending down an enormous amount of points. And if we toggle off the vegetation class, we can see that underneath that dense vegetation there, we've got plenty of ground coverage. Actually, some of that is probably, yeah, there we go. So there's just our ground surface points, along with some buildings in the background. But I think this is a good example of kind of the step in evolution of UAV LiDAR towards larger areas, more endurance, and overall more data to help solve problems.
Yeah, the one thing I'll add, to your comments, Conrad, is that this is a multi-laser system, and it's incredibly important. Part of our process with these automotive-based LiDAR sensors is to calibrate each laser, and that's all part of our process here. Is to really optimize the laser calibration to get the best point cloud that we can get. It's part of our flight line matching process. But the overall, this sensor, I think you're going to see in the range of ±5, ±6 centimeter accuracy. So it's a thicker point cloud. There's no doubt. You have all these lasers that are forward looking and rear looking, and we're combining this with a MEMS IMU. So you're in that range of about 5 ±5 centimeters accuracy for this system. And but the nice thing is that finally with this automotive sensor we can get it to that higher altitude required for fixed wing flight and stay below regulation height of 120 meters. Oh, it's just because we didn't, here it's, I think, turn off the never classified points. Conrad?
The buildings and keep them away.
You did what? Yeah, just turn off, if you uncheck, I don't think the buildings were properly classified.
There was so for everyone who can't see the question, one of the users asked about some of the classification. That's the conversation they're having right now.
Ah.
Yeah, so.
Okay, yeah, sorry, I'm not watching the chat.
No worries. All right, go ahead and continue to your next point cloud there, Conrad.
Thanks, Grayson.
So the next two data sets we're going to look at are both acquired from the TerraHawk CW30 and both using a Ranger LRT. I think Sam and Grayson have both kind of gone over this on one of the previous slides. So I will jump straight to some of the data. The first point cloud is a corridor with power lines, a utility corridor. This data set is a little bit over 7 kilometers. It's really a small corridor compared to what the CW30 and Ranger LRT are capable of. We flew this at 150 meters AGL, cruising around 28 meters per second. Overall, that yielded approximately 50 points per square meter total. And that's comprised of a out and back flight line. So 2 flight lines yielding 50 points per square meter. At the speed we were going, this is a total of about 10 minutes of acquisition time. So really just a fraction of what this system is capable of, but a pretty sizable project by most other systems standards. We're looking right now at RGB values that are from satellite imagery, so not super impressive. Let's change that and look at a composite.
And Conrad, while you're changing that setting, I just wanted to announce to everyone in the chat box, we've also posted the URL to view this data yourself, also in our online viewer.
And another addition to that, with the CW30, we do, I think you said 7 pounds, is that what you said? So I think it's max 6 kilograms is the payload capacity of it. Sure, max, but the Ranger LRT is right around 4.7, and if 4.8, if we add the camera, we can fit in a Sony a6000 camera in addition to this to acquire both RGB and LiDAR. And that's about the capacity limits of the CW30 at the moment. And we're getting right around an hour-and-a-half flight time when you combine the camera and the LiDAR sensor together.
So if we take a look at the point spacing on the ground, we can see we've got nice even point spacing and a really good density. For these systems, we're using about 100-degree field of view for the LiDAR. And in 2 passes, we can see that yielded really great detail on the infrastructure. With this data, it would be really easy to model the wires and make nice detailed models of towers or any kind of other infrastructure that you might be surveying. Another interesting thing about this is the width that we were able to cover in this corridor. We take a look at the measurement tool. We were getting nearly 500 meters across. That's considerably larger than what is typically required for a utility corridor inspection. And this was with 2 passes. So really it takes away the fear of not collecting the swath that you need. And we can collect the data and be confident that we have plenty. As with any Ranger system, we've got excellent vegetation penetration. So we can toggle off
I'm unmuted.
some of these levels and take a look at just the ground and the infrastructure.
The last question you answered.
The one thing to note as well of the Ranger is that it is a 1550 nanometer laser, so we are getting about 40 times, the laser pulse is 40 times more powerful than a 905 nanometer laser, and this is why we're getting that detail of not only vegetation penetration, but also you'll see grounding wires and whatnot. And I mean, of course, it's if you want to guarantee you're going to get that black grounding wire on some of these distribution lines, then a 1550 nanometer laser is really always the best choice. But you can even see on Conrad's screen that we're picking up well, not only the conductors, but the insulators and a lot of the attachment points. So it really is an incredible detail for flying at 28 meters per second.
Yeah, the shield wires are always something that is kind of iffy. You have to plan accordingly. So it's great to be able to model those so easily. There's pretty much continuous point coverage of those.
So yeah, so what's the next?
Yeah, let's move on to the next data set that we're going to look at.
And one cool thing, as Conrad pulls up this data set, one cool thing is that a huge part of the woods in the next data set, they had overgrown this terraced farmland that a lot of people didn't know was there. So with the Ranger LRT being able to penetrate that dense vegetation, we were able to see the ground and then also see that it had once been leveled out in parts. And I'm sure he'll show you a little bit of that.
Yeah, so this data set is from a pretty much the same setup as that utility corridor data set. The main difference here in terms of hardware is that there was also a 42 megapixel full frame camera collecting RGB values. So here we've got a really nice colorization to our point cloud. It was also flown with overlap to allow for creation of an orthophoto. Like the last data set, this is flown from 150 meters AGL at 28 meters per second and achieving about 15 points per square meter per flight line on average. So flying a normal survey style mission with enough overlap for orthophoto production, that ends up yielding you pretty high density LiDAR. I think with a camera, the system, like Sam mentioned, is capable of collecting around 20 kilometers squared. Without, you can, I think, at least double that. I'll try to find that area that Vu was mentioning, because there's some interesting topography in this data set.
Yeah, the Ranger LRT is a single line scanner. So with any single line scanner, you do get the cleanest point cloud. And you can really see it in that link that Vu sent you guys. You can do some profile sections of the runway to get a good idea of the detail. But on the opposite side of where you are, Conrad, is that vegetated area, and you can also hide the trees to show that terracing.
Right.
So at 150 meters, sure. We flew this also at 250 meters. So I'd say max recommended probably would be 250 at 820 kilohertz. Then you're going to have to jump down to 600 kilohertz once you start going north of there. But using our flight planner, you guys can get a good idea of what to expect density-wise from this, from the CW30 combination. But I think you guys can see the benefit of this whole VTOL transition system from let's face it, most of the areas with LiDAR that you want to map are vegetated, right? And in finding a nice clear runway to take off and land from in these vegetated areas is impossible. So having a VTOL system, you can take off and land in a much narrower landing zone, LZ, And it just makes it much more flexible when you're trying to plan out a job. So yeah, it's in the point cloud viewer. It's you know, via the web. It may take a while to load depending on the graphics card. If you guys are viewing these, make sure that you do switch Google Chrome or Firefox, whatever web browser you're using, to utilize your graphics card and not the internal Intel graphics card. You'll get much better detail. And if any of you are experiencing issues displaying the points, you can click on that little eye at the top left, and there's a button that is the eye dome lighting, and that does cause, depending on so go to the, yeah, but depending on which web browser you have, you can turn off the eye dome lighting, and that the problem goes away. So we highly recommend Firefox and Chrome. Firephone, I like that. Firefox and Chrome to view these point clouds. All right. So, are there any other questions on the? So, yeah, this short webinar was really just to focus on the benefits of these VTOL fixed wing configurations. Sure, it's not it's not going to solve, you know, all surveying problems, but it's another tool to add, and having that flexibility of using that same payload on a multi-rotor and this fixed wing really goes a long way, and to give you those options. So it's quite exciting with these VTOL systems to finally get into this arena of mapping, you know, somewhere in the region of 30 square kilometers. Albeit we will be faced with regulation on weight and yet on line of sight, but at least even with the CW20 being under that 55-pound weight limit, you could still cover a lot of area and not have to take off, charge, land, take off, land, charge, take off, you know, that whole leapfrogging. You can cover a lot of area in one single flight. And if you guys, I don't know if you open for questions after this? Or?
That's right. So yeah, if you have any questions, please share them in the chat or in the Q&A box at the bottom of your screen. And while our team answers those questions, I'd like to remind them, if you can respond to everyone and summarize the question, because sometimes when people send in questions, it only goes to the panelists. And while they're busy typing away at that, I wanted to point out, 1 second. So we'll be at AUVSI next week. A lot of our team is flying out to Denver. We're excited. We'll be at booth 735. Now, how you're going to remember that, I have no idea. But if you go there, we'll be at AUVSI. We'll have a really nice booth. And we'll be there to talk to you about any of these systems, not just the ones that we discussed today, but a lot of the other ones that we sell as well.
We'll have the Terrahawk CW20 on display.
And we'll have the Terrahawk CW20 on display. Now, it's quite a large aircraft, but it's really light. And so you'll get to come up and poke at it and explore it a little bit. And then a few weeks after that, we're going to London. So Eric Agnello, Director of Sales, will be going to Geo Business in London.
With the CW20.
Not with the CW20. That'd be a disaster. But
can that go in my carry-on?
And we'll fold it up into his carry-on. But if you happen to be one of our viewers in London, just jog up the stairs, or there's a balcony overlooking the floor, right where all the breakout sessions and workshops are. So we'll be there in booth P5, and actually it'll just be Eric, so he'll be manning the fort for a few days, working really hard. And then, so now I just wanted to show you in this last screen, Conrad, if you'd advance to the next screen. So Eric and the others will continue answering questions on the chat, but I wanted to let Eric have the mic briefly just to talk a little bit more about the Scout series that we're announcing this week and next.
Hey guys, how's it going? So we are essentially relaunching our Scout series. For those of you that have been stalking us for a minute, you're probably aware of the Scout, the original Scout Phoenix LiDAR solution, which featured the VLP-16 puck light. We're now launching a whole new Scout line, which is going to feature all three Velodyne sensors. So not only the VLP-16 puck, but now we're also doing a Scout 32 with the HDL32E sensor, and also the Scout Ultra featuring the new Ultra puck. And the idea here is to offer a larger variety of sensor options in a smaller, lighter, and more cost-effective payload configuration. Many of you know that up until this release, that for instance, the HDL32E was only available in either our AL332 or T32 configurations. So the Scout is going to bring more versatility, lower cost, lower weight, and it's a great line for people, you know, just kind of beginning their journey in the LiDAR field. So we'll be officially launching that at AUVSI next week. There's going to be you know, more information and data sets and news to come. But if anybody has any questions on these new systems, please email us, info@phoenixlidar.com, or you can email me directly, Eric, E-R-I-C, @phoenixlidar.com.
Thanks, Eric. And Conrad, if you'd go to the last screen. So I want to say thanks again for everyone who tuned in, and especially those who have been with us from the beginning. Remember, the purpose of these webinars is to continue to add value to all of our clients around the world. Things like the flight planner, when we spent all this money developing it, we made it free for our users. So the goal really is to make UAV LiDAR super simple, especially for our clients. And also for anyone who's learning more about LiDAR and wanting to get into it, that's the other purpose of these webinars. So to that end, if you have any feedback or topic ideas, questions, suggestions, you can email me at marketing@phoenixlidar.com. I do read all of those emails, and I scour our social media every day. So all of our handles are the same, Phoenix LiDAR. So it's on Instagram, Twitter, Facebook, YouTube, and even LinkedIn. So without further ado, what we're going to do is we're going to mute all of ourselves and then just hang out here for a bit while everyone signs off, just in case there are last-minute questions. But again, thank you all for tuning in to our 4th webinar, and we'd love to hear back from you to know what you'd like to hear for the 5th. By the way, you see that drone on the door? It's a really cool drone. I designed it. All right, bye everyone.